Good afternoon, everybody. Today we want to see the next topic of this chapter, Haloalkanes and Haloarenes. In previous class, already we had seen that haloalkanes means what, as well as haloarenes means what. So it is known for us that haloalkanes. So this Rx indicate the haloalkanes and this Arx indicate the haloarenes. So the haloalkanes means what? The halogenated compounds, those derived from the open chain hydrocarbons. They referred out term as a haloalkanes, or you can say the halogenated compounds, those obtained from or those derived from the saturated aliphatic hydrocarbons by replacing the hydrogen with the halogen. So they are the haloalkanes, and the halogenated compounds those obtained by replacing the hydrogen from the aromatic ring, they referred out term as a haloarenes. So these haloalkanes and haloarenes may be classified as follows. So according to your M.Sc content, on the basis of number of halogen atoms, these haloalkanes and haloarenes, they had been classified into the different types as like it means that depending upon whether they classified depending upon whether they contain 1, 2 or more than 2 halogen atoms. They are classified as monohaloalkanes or monohaloarenes. Then dihaloalkanes or dihaloarenes. Then polyhaloalkanes and polyhaloarenes. I like that. So whenever single halogen atom is present in the haloalkanes, they are the monohaloalkanes. Whenever the single halogen atom is present in the haloarenes, they are the monohaloarenes. Similarly, whenever the two halogen atoms are present in the haloalkanes, they are the dihaloalkanes. And whenever the haloarenes possess or having the two halogen atoms, they referred as dihaloarenes, and so on, and like this. So see here, monohaloalkanes. So this C2H5X, this is the ethyl halide, and this possess or having the only one halogen atom. Hence this is a type of monohaloalkane. This is the alkyl group and this is the halogen atom, and single halogen atom is present here. That is the case of monohaloalkane. Then after this, the specific example is ethyl chloride. And the IUPAC name of this ethyl chloride is the chloroethane. This chlorine is attached to the carbon number 1 here, and this is the chloroethane. Already, this is the saturated aliphatic hydrocarbon where the single bond is present, and this is the case of chloroethane. So this is the example. This is the nice example which is given in your NCERT of the monohaloalkane. Then here monohaloarenes. So here this is the aromatic ring, and this aromatic ring exhibit the presence of the single halogen atom. And hence this is the case of monohaloarene. Here the halogen is directly attached to the ring, and the specific example is you can say the benzyl halide. This is the benzyl halide, and the specific example is chlorobenzene. So the benzene ring, from this benzene ring, one hydrogen atom replaced by this halogen chlorine, and hence this is the chlorobenzene. Then see here, the next after the monohaloalkanes and alkenes, the next group, that is the dihaloalkane. In dihaloalkane already name itself indicate the meaning. Name itself indicate the meaning. These are the haloalkanes, those possess or having the two halogen atoms. Possess or having the two halogen atoms. But on the basis of the position of these halogen atoms, these dihaloalkanes further classified into the two types. Further classified into the two types. So see here they are of two types. That is the gem dihalides and vicinal dihalides. Vicinal dihalides. It means whenever the two halogen atoms whenever these two halogen atoms adhere or attach to the same carbon atom, then that is the case of gem. So gem means the both halogen atoms, here these two halogen atoms, they attach to the same carbon atom, and hence they considered as gem dihalides belongs to the dihaloalkanes. Then again see here, this is the second type of dihaloalkanes, and that is, in this case what happens, these two halogen atoms attach to the adjacent carbon atom, this carbon and this carbon, they are neighbors of each other. So the two carbons are in vicinity of each other. They are in vicinity of, it means in close to each other. And when the two halogen atoms separately attach to the two neighboring carbon atoms, that is the case of vicinal dihalides. So this is the difference between vicinal and the geminal dihalide. And this geminal dihalides as well as the vicinal dihalides both belongs to the dihaloalkanes. Then here in this case, see the name of this one is the 1,1-dichloroethane, and then this is also known as, this compound is also known as the ethylene chloride. This is also known as ethylene chloride. This J group comes with this suffix as like leading, leading. So ethylene chloride, and in abbreviated form it also referred or termed as, in abbreviated form this compound also referred or termed as gem dihalides. This is known as the gem dihalides. Then here in this case, this compound, the name of this compound is 1,2-dichloroethane. So this is the IUPAC name, this is also the IUPAC name, this is the common name, here, and this common name is known as ethylene chloride. This is the ethylene chloride, and this ethylene chloride is also abbreviated as, that is the weak dihalide. This is the, as belongs to vicinal group, that is weak dihalide, and as this belongs to the geminal group, this is the gem dihalide. So these are the two types of dihaloalkanes. It means on the basis of the position of halogen atom in the respective dihaloalkane. There are two types, gem and the vicinal. It means whenever the both these halogen atoms occupy the same position of the same carbon atom, then you have to call for them as gem dihalides. And whenever the two halogen atoms they occupy the position separately of the neighbor carbon atoms, of the adjacent carbon atom, then you have to call them as a vicinal dihalides. So in this way, these are the dihaloalkanes. Then next to this, dihaloarenes. Already name itself indicate that these dihaloarenes possess or having the two halogen atoms, those directly attached to the respective aromatic ring. Here this is the aromatic ring, and these two halogens, those indicated with the X, because already you people familiar with that. The X stands for the halogens. And halogens are represented by the chlorine, bromine, iodine, and fluorine. So here this is the case of dihaloarene. And the specific example of this dihaloarene is the 1,2-dichlorobenzene. So this is the IUPAC name. On the basis of the position of this halogen atom, here this compound is also known as ortho-dichlorobenzene. These are the ortho positions, and these are the meta positions, and these are the para positions. Already people know this. So here, as the halogen atom is attached, one halogen atom to the ortho position, This compound is also known as the orthodichlorobenzene. Orthodichlorobenzene. So in this way, these are the monohaloalkanes and these are the monohaloarenes. These are the specific examples. These are the general examples. Here this is the general example. This is specific example. Here this is general example. Again these are the specific examples. These two are the specific examples. In this case also, this is the general example for you people, and this is the specific example in regard of these dihaloarenes and dihaloalkanes, as well as the monohaloarenes and the monohaloalkanes. And the next, that is the polyhaloalkanes and polyhaloarenes. So after knowing the monohaloarenes, then the dihaloalkanes and dihaloarenes, and the next group is the polyhaloalkanes and polyhaloarenes. So see here, these polyhaloalkanes available in two forms, in tri as well as tetra forms. So see here, this is carbon tetrachloride. So this is the polyhaloalkane in tetra form. Here 4 halogen atoms are there. In this case 4 halogen atoms are there. Then whenever for these three cases you have to see here, polyhaloalkanes in triform. Why? Because here this chloroform, bromoform, iodoform, these all represent as a polyhaloalkanes. All these three as well as this also represent as a polyhaloalkanes. So in these three, the 3 halogen atoms are there. Again, this is the general example. This is the propyl halide. This is the case of propyl halide because here single bond arrangement is there as well as 3 carbon atoms. So accordingly, prop is there whenever the 3 carbon atoms are present. So this is here the 3 hydrogen atoms have been replaced by the 3 halogen, and the resultant compound is propyl trihalide. So this is the case of trihaloalkane. It means polyhaloalkanes name itself indicate the meaning. The haloalkanes, those possess or having 3 or more than 3 halogen atoms attached to the same carbon atom or different carbon atoms. Here these are the 3 halogen atoms, and they attach to the same carbon atom. But in this case, the 3 halogen atoms attach to the different carbon atoms. So such type of compounds, such type of the combinations referred out as polyhaloalkanes. They belongs to the haloalkanes. Then next, see here. So this is the chloroform, this is the bromoform, this is the iodoform, and this is carbon tetrachloride. Means the tetra form of polyhaloalkane, and these 3 represent as a triforms of the polyhaloalkanes. So all these are the polyhaloalkanes belongs to the haloalkanes. Then polyhaloarenes. So here also the more than 2 halogen atoms are present in the aromatic ring. And here in this case, see here, these halogen atoms directly attached to the aromatic ring. And the resultant compound referred out as polyhaloarene. So this is the trihaloarene. This is the general example. This is the general X indicate the halogen atoms. Then the specific example is like this. Here this is the 1, 2 and 3rd position. So 1, 2, 3 trichlorobenzene, because this is the benzene ring, and the halogen atom, these chlorine atoms, they directly attach to the respective carbon. They directly attach on the aromatic ring to the carbons of the aromatic rings, and hence this is the case of polyhaloarene. Belongs to the haloarene. Monohalo compounds may further be classified according to the hybridization of carbon atom hybridization of carbon atom to which halogen is bonded. So this is the one case for your study in NCERT. In this case, these are the mono-halo compounds in which the hybridization of carbon, this halogen bonded carbon exhibit the sp3 hybridization, and another class is also there where the halogen atom is bonded to the carbon that having the sp2 hybridization. So this is the one class here where the halogen atom is bonded to the such carbon that had a sp3 hybridization. So compounds containing sp3 carbon halogen bond. So this class include the three types, like alkyl halides, then allylic halides and benzylic halides. So everywhere it comes to your eyes that in each of the compound belongs to all these three groups, only one halogen atom is present, hence they are the monohalogen compounds. All are the monohalogen compounds here, those represented by me on this board. So see here, here in this case the halogen atom is bonded to an alkyl group, generally to an alkyl group. So here this is the alkyl group, here this is also the alkyl group, this is the propyl group. So accordingly everywhere they are attached to the alkyl groups. They form a homologous series, everywhere the homologous series with the general formula is CnH2n plus 1 X, because everywhere the only one halogen atom is present, and they are further classified according to the nature of carbon, to which halogen is attached. So see here, this halogen is attached to this carbon, here also to the carbon, here also this attached to the carbon, and this each carbon had a different nature. Why? Because this carbon is in attachment of the only one carbon, and this is primary carbon. This carbon is in attachment of the two carbons, because one carbon here from this alkyl group, one carbon here from this. So the carbon is in vicinity of the two other carbons. In this case also this carbon is in vicinity, it means in the attachment of the two other carbon atoms. Here this is in the three carbon atoms. So this carbon in the attachment of three other carbon atoms, and to this carbon halogen is bonded. So this is the tertiary carbon, this is the secondary carbon, and this is the primary carbon. So on this basis, so according to the nature of carbon atom to which halogen is attached, they are further classified, like the primary alkyl halide, secondary alkyl halide, and the tertiary alkyl halide. Halogen is bonded here to the tertiary carbon, here to the secondary carbon, here to the primary carbon, because here this carbon is in attachment of one carbon, this is in attachment of two carbons, this is in attachment of the three other carbons. So accordingly, this also known as the first degree alkyl halide, second degree alkyl halide, and third degree alkyl halide. So these are the general examples here mentioned in your NCERT. The specific examples are like this. So see here, this is the 1-chloropropane, first degree alkyl halide, because 1, 2, 3 carbons are there, and this is the propane, and the chlorine is attachment of the first carbon. So 1-chloropropane, this is first degree alkyl halide. Here this is the second degree alkyl halide, and here this is the third degree alkyl halide, because here this halogen is bonded to such carbon which is in the attachment of two other carbons, and here this halogen chlorine is bonded to such carbon which is in the attachment of other three carbons. So this is the third degree. The name of this one is the 2-chloropropane, and this one is here we have to consider this chain or this chain. So accordingly, this is 2-methyl propane, 2-methyl, and this 3 carbon propane, because everywhere the single bond is present, hence all are the alkanes. So these are the alkyl halides, and like this classification had been given on the basis of the nature of carbon atom to which the halogen is bonded. Then the allylic halide, these are the compounds in which halogen atom is bonded to an sp3 hybridized carbon atom. This halogen is bonded to this sp3 hybridized carbon. Here this carbon is sp3 hybridized carbon. Here also this is the aromatic ring, and this halogen is bonded to the sp3 hybridized carbon. This carbon is sp3 hybridized carbon here. This carbon sp3 hybridized. This is also the sp3 hybridized carbon. Adjacent to this sp3 hybridized carbon, adjacent to the carbon-carbon double bond. Carbon-carbon double. Here also this sp3 hybridized. This is the sp3 hybridized carbon. This is also the sp3 hybridized carbon. And this sp3 hybridized carbon, that is to an allylic carbon. This one is the allylic carbon. This is also the allylic carbon, and this is sp3 hybridized carbon adjacent to the carbon-carbon double bond. This is also adjacent to the carbon-carbon double bond. Here carbon-carbon double bond is there, and this sp3 hybridized carbon is in adjacent to this, and the halogen is bonded to this carbon. So such type of compounds, such type of the monohalogen compound, monohalogen referred or termed as allylic halides, where the sp3 hybridized carbon atom adjacent to the carbon-carbon double bond, and this sp3 hybridized carbon atom referred or termed as allylic carbon. Here this is the allylic carbon. So the examples are like this. Here this is the 3-chloropropene, and this one is these are the specific example. This is the 1-chloro but dash 2 dash in, 1-chloro but 2-in. Here En is the suffix. Here also En is the suffix because the compound pages are having the double bond here, and this one is here. This is the sp3 hybridized carbon here. sp3 hybridized carbon. This is also the sp3 hybridized carbon. This sp3 hybridized carbon bonded with the carbon-carbon double bond. This is also bonded with the carbon-carbon double bond, and the halogen is bonded to such sp3 hybridized carbon atom which is adjacent to the carbon-carbon double bond. Here halogen atom bonded to the sp3 hybridized carbon atom adjacent to the carbon-carbon double bond. Hence these are also the allylic halides. So the third case, that is the benzylic halide. These are the compounds in which halogen atom is bonded to an sp3 hybridized carbon atom attached to an aromatic ring. So see here, this is halogen atom bonded to this carbon. This is the sp3 hybridized carbon atom attached to the aromatic ring. Here also this is the halogen atom bonded to this sp3 hybridized carbon atom. This one attached to the aromatic ring. Again here what happens, this sp3 hybridized carbon atom attached to the aromatic ring where the carbon-carbon double bond is. Here also the carbon-carbon double bond is there. So accordingly this is the first degree benzylic halide, and this is the first degree benzylic halide, and this is the second degree benzylic halide. This is the, whenever this R double dash, this R dash is the methyl group, R double dash is the hydrogen, then this is the secondary benzylic halide. But whenever you consider here this R double dash equal to R double dash, it means whenever this is also methyl group, this is also methyl group, then this is the third degree benzylic halide. So the specific examples are like benzylic chloride here, and this is the 1-chloro 1-phenyl ethane. This is the second degree benzylic halide, and this one is the first degree benzylic halide. Because already this carbon is in attachment of the only one other carbon, and this carbon is in the attachment of the two other carbon atoms. So this is the secondary. Yes, this is the second degree benzylic halide, and this is the first degree primary carbon. Yes, this is the first degree benzylic halide. So these are the general examples. For the benzylic halides, and these are the specific examples for the benzylic halides. So in this case, these are the allylic halides, and these are the benzylic halides, and these are the alkyl halides. So these are the monohalogen compounds according to your NCERT content. Whenever you feel this discussion nice, then you do the like for this video, as well as try to share with your friends and relatives, and don't forget to subscribe the channel. Thank you for all of you to listen peacefully.